Hi guys, in this video we're going to use Google Sheets to do some very basic statistics. We're going to do descriptive statistics, which also kind of rolls up into what's called exploratory data analysis, which is basically once we have our data, we want to explore it and see if there's any interesting patterns or insights that we might want to look into further. Okay, so in this video we're going to focus on this little data set here. Okay, so here you see we have two variables, one's age and one's gender. Age is clearly numerical, as you can see from the values, and gender is clearly nominal or categorical. Okay, as you can see from the values on their gender, the levels gender takes are male or female, M or F. Okay. Furthermore, notice that this data set, although very small, is bivariate. There are two variables for each, in this case, person. So each subject is represented by a row here. So this is a 40-year-old male, this is a 25-year-old male, this is a 27-year-old female, and so on. Okay? So this represents our sample data. And in this section over here, I've set up some very interesting and important descriptive statistics that we might want to use to summarize this sample data. Okay, so let's first start off with the sample size. Now, sample size is often symbolized with the lowercase n in stats courses, okay, and in statistics. So let's use some of Google Sheets functionality. So we can use equals count, and if we highlight a numerical column of numbers, or shall I say, if we highlight a column of numbers, it'll count how many numbers are there, and that's equal to our sample size. Okay, so equal count did that for us. Now the mean, so this is the sample mean for age. Okay, so this will give us an idea of where age is centered. Okay, so equals average, and then open parentheses, highlight age, enter. So we see the average age is 37.6 years. Median, so median, member, is also a measure of central tendency, except it's more resilient to outliers. It orders the data either ascendingly or descendingly and picks out the middle number. Okay, so here equals median. We'll go through that whole process and give it to us in one shot. So equals median, open parentheses, highlight all the values for your numerical variable, hit enter. Okay. Next, we move to some measures of central tendency that are very important. Measures of spread that are very important. So we'll start with sample variance. So equals VAR, and you'll see that you get a few choices here. Make sure you choose VAR A, as that is the sample variance formula. VAR P is for population variance. Remember, sample variance we divide by n minus 1, and in population variance we divide by n. So it's important that you choose var.a if you have sample data. Okay? And standard deviation, we can either take the square root, so SQRT, of variance, or we could have also arrived at that number using STDEVA. Again, A for sample, and highlight the data, and you see that we get exactly the same values. In fact, if I increase the decimal places here, you see these two are equivalent. Okay, so we don't need to keep both of them. By the way, you can choose to round by increasing or decreasing number of decimal places displayed. So that's our standard deviation. So we have an idea of how spread out the data is. Another measure of spread, less sophisticated, is the range. So we can use two functions here, max and min. So max will tell us the maximum age, so that's probably 50, so 57 is probably the oldest, that's the one that pops out to me, minus the minimum age, so min, open parentheses, And there's our range. So our range is 39 years. Okay, from the youngest to the oldest person in our sample data. Okay, next let's move over to our categorical variable, and notice that we can't treat the categorical variable the same way we treated the numerical variable. We can't add, divide, take the square root of something that has categories instead of numbers. So we have to treat this altogether in a different way. And it turns out the way we could summarize a variable like this, at least initially, is to calculate things like frequency and the proportion. So, for example, let's start with just counting how many males there are. Okay, that seems like it's a start to summarizing the data. So we can use the function equals count if, open parentheses, highlight the gender column, comma, and in quotations put the criteria that you want to count. So it's not cap sensitive, so you can put lowercase m. So it will only count when it finds an m. So it found 6 males, and we could spot check that. 1, 2, 3, 4, 5, 6. So it's doing the right thing. Next, for females, we'll do count if, highlight, comma, in quotes, put f. So it only counts the females. Obviously, the remainder of the 10 are females. So we have 6 males, 4 females. If we want to be slightly more sophisticated, we might consider calculating the relative frequency or the proportion of males and females. So to do this, we can do it in we can do a count if in the numerator. So this will be a review. So we just did this. So this will tell us, this will give us 6, and what we want to divide by the total number of observations. So count, and we have to do a count A because we're counting text. So it's going to be 6 over 10, 60%. Okay, and if you leave that as, you can convert that to a percent or just a regular number, however you feel you want to interpret it, doesn't matter. Okay, and we'll do the same thing for females. So equals count if, this time we're going to count only females, so I put criteria F. If I just hit enter, I'm going to get 4, but I want to divide this by 10, or count A, which is going to count how many observations there are. And I'm doing count A as opposed to just plain count because regular count won't count text. It'll give me back 0. It'll only count numbers. So count A will count text. So it's 4 over 10, we get 40%. Okay, and I could convert that to a plain number, or you could leave it as a percentage, however you feel comfortable. Okay, so here is a snapshot of some very important basic descriptive statistics for our bivariate sample data, where we dealt with a numerical variable and a categorical variable, and we get a good idea of what's going on with both of these variables by looking at these summary statistics. So I hope this was helpful. We're going to use Google Sheets in this playlist, and we're going to develop some more interesting and sophisticated statistical techniques, trying to stick with Google Sheets this time. Okay? If you want to learn how to do this stuff in Excel, I have tons of tutorial videos on doing these type of operations in Excel. If you want to be even more sophisticated and learn how to use it in a professional statistical software like R, I also have tutorial videos on R on my channel. So till next time, subscribe, like, share, and have a great day.